Hey everyone, welcome back to part 2, where we're still working with coordinate planes. Just to refresh your memory, example 1 dealt with plotting points and writing down ordered pairs. And in example 2, we practiced finding the distance between 2 points on a coordinate plane as well as using absolute values. Let's pick back up with example 3, where we're going to find the missing point of a rectangle. Since rectangles have 4 corners or 4 vertices, we need to have 4 points on a coordinate plane to create a rectangle. Notice here that you're given 3 points, U, J, and I, and we're missing M. I'm using these 4 letters because I really like Muji pens. First, I'm going to show you how to do this on a coordinate plane, then I'll show you how to do this algebraically. First, I'm going to plot U down here in quadrant 3, then I'm going to plot J here in quadrant 4, and we'll plot I here in quadrant 1. At this point, we have 3 of the vertices drawn, and we can connect the dots to create 2 sides of our rectangle. Here's segment UJ, and here's segment JI. Pause the video and think about it. Can you figure out where the last point M has to be to create a rectangle? To be a rectangle, the opposite sides have to be the same length. Let's see how long segment IJ is. Here we can say this is going to be 2 units, and over here we can see this length is going to be 8 units. Together, we know that IJ is 10 units long. If that's the case, the left side also has to be 10 units long. Now let's look at segment UJ. From point U to the y-axis, we have a distance of 4, and the distance of J to the y-axis is 5 units. Altogether, UJ is going to be 9 units long. That being said, this top part also has to be 9 units long across. Seeing where these 2 segments intersect, we can now label this point M. The coordinates of point M are going to be -4, 8. Each of the sides are 10 units long, and the top and bottom are also 9 units long. And since each of these segments meet at 90-degree angles, we know that by definition, this is a rectangle. So what if you didn't have graph paper? Do you think you could still figure out this missing point? Let's see if we can see a pattern in the values in ordered pairs. First, notice that these x values are both 5. Then look at these y values. These y values are both -2. And following that, these x values match. And you can see here that these leftover 8s also need to match here. Now you have to ask yourself if you think that this is just a coincidence or if this is actually a rule that we can use for future problems. Points that are left and right of each other will always have matching y values. And points above and below each other will always have matching x values. If your points are written in order, they will always have matching values when they're next to each other. These x's match, these y's match, and these x's match, and since M and I connect, these 8s would match as well. Let's try one more together here. Pause the video to see if you can do it on your own, then unpause it to see how you did. Since our graph can't accommodate this -15, we're not going to be able to plot all of these points here. If you'd like to, you can create your own coordinate plane that goes all the way to -15 so you can find the coordinates of point T. However, since I've given you them in order, I'm going to try using that strategy that I just went over in the last example. First, we should notice that points M and A have matching y values of +4. If I were to look at this roughly on a coordinate plane, point M would be somewhere over here in quadrant 1, while point A would be somewhere over here in quadrant 2. Since M and H are on the ends, they're going to connect. Since they have matching x values of 2, we know that H is going to be beneath M. And that leaves T. T must be over here somewhere in quadrant 3. To complete the rectangle, T must be beneath A, so it has to have the same x value. Since A and T are on top of each other, this has to be a -15 for the x value. And since T and H are left and right of each other, then their y values have to match. The coordinates of T are going to be -15, -8. If these still seem a little strange to you, I encourage you to take some graph paper and plot these points down to see if it makes sense. In example 4, we're going to practice finding the perimeter and area of a rectangle on a coordinate plane. Pause the video and plot the points S, O, U, P on your own. Here are the 4 points S, O, U, P on a coordinate plane. Connecting these 4 points, we'll get a rectangle. To find the perimeter, we have the formula 2 times the length plus 2 times the width. Let's call PU the length and SP the width. While you can find the length of PU on the coordinate plane, you can also use absolute values to figure it out without a coordinate plane. Since the y values match for UP and the x values are in different quadrants, we can take these x values here and add their absolute values. The absolute value of 10 plus the absolute value of -3 is just going to equal 10 plus +3. Since 10 plus 3 is going to be 13, the length of PU is 13 units. Since PU and SO have the same length, we have 2 of these 13s, or we can say 2 times 13. Now let's find the length of SP. Since the x values match between S and P, we can just look at their y values to figure out the distance between these points. Since S and P are in different quadrants, we're going to add their absolute values to find out the distance between them. The absolute value of 8 is 8, and the absolute value of -2 is +2, and 8 plus 2 is going to get us a distance of 10 units. Since SP and OU have the same length, we can say that we have two of these measurements that are 10 units long. Simplifying this a bit, the 2 times 13 is going to be 26, which is the bottom and the top, and the 2 times 10 is going to be 20, which is the left and the right. Adding these two measurements together, 26 plus 20 is going to be 46. The perimeter of this rectangle is 46 units round. Now that we know the perimeter, let's find the area. To find the area of a rectangle, we multiply the length by the width. Since we already know the length is 13 units and the width is 10 units, we can multiply 13 times 10 to get a total area of 130 square units. This represents the area. Just a reminder, the 46 units represents the perimeter or the outside of the shape. If you were to count around the entire rectangle here, you would count 46 of these little unit lengths all the way around. On the other hand, the area of 130 units squared represents the fact that there are 130 of these squares inside of this rectangle. While perimeter represents a one-dimensional length around the outside of a figure, area represents a two-dimensional space inside of a figure. Now it's your turn. Pause the video and try to find the area and perimeter of the rectangle formed by the letters M, A, T, H. Plot these points down and see if you can find the area and perimeter. Here's M, here's A, here's T, and here's H. Connecting these 4 points, we get a rectangle. Let's find the length of segment MA using absolute values. First, notice that their y values match here of 6 and 6. Since their y values match, we can add the absolute value of their x values since they're in different quadrants. To find the distance between point M and point A, we're going to take the absolute value of negative 8.5 and add it to the absolute value of positive 2.5. The absolute value of negative 8.5 is just positive 8.5, and the absolute value of 2.5 is going to be 2.5. Adding these two together, we're going to get a distance of 11 units. At this point, we know the top is going to be 11 units and the bottom is going to be 11 units. Now let's see how far apart points A and T are from each other. Since points A and T are above and below each other, they have matching x values. If that's the case, we can just compare their y values to find their distance. Since they're in different quadrants, we're going to take the absolute value of 6 and add it on to the absolute value of negative 3.5. The absolute value of 6 is going to be 6, and the absolute value of negative 3.5 is going to be 3.5. Adding these two together, we're going to get a total distance of 9.5 units. If this right side is 9.5 units, then this left side is definitely also 9.5 units. Now that we have the rectangle plotted and the side lengths measured, pause the video and see if you can find the area and perimeter. While it's up to you, I'm going to label the length on the bottom here and the width to the side. If that's the case, we're going to say 2 times the length, which is 11, plus 2 times the width, which is 9.5. 2 times 11 is going to be 22, and 2 times 9.5 is going to be 19. Adding 22 and 19 together, we're going to get a perimeter here of 41 units. Now that we have the perimeter, let's find the area. Area is just equal to length times width. Since we know our length is 11 units, we can use an 11 here and multiply it by the width, which we know is 9.5. Thinking back to our unit on the standard algorithm, we can multiply 11 times 9.5 using the standard algorithm. (11 times 9.5 is going to be 104.5, and this is going to be units squared. If you wanted to see how many little squares are inside this rectangle, there would be 104.5 of them. If you wanted to know how many edge lengths you'd walk along the outside, you'd walk along 41 of them. And here's the final example. In example 5, we're going to practice reflecting points across each axis. Let's start with practicing reflecting points across the x-axis. Let's look at this first point A, which is located at negative 2, 7. Here we can see it plotted in quadrant 2. We're going to reflect point A across the x-axis here. One way you can think about this is that point A is a person and the x-axis is a mirror. If point A was looking into the mirror, how far into the mirror would its reflection be? Whatever the distance is between A is and the x-axis, its reflection should be the same distance away from the axis. Since point A is 7 units away from the x-axis, its reflection should also be 7 units away from the x-axis. To write the reflection of a point, we use the same letter, which is A, and we put a little tick mark next to it when we read this as prime. The reflection of A across the x-axis is A prime. The location of A prime is going to be negative 2, negative 7. Now let's look at point B, which is 4, negative 3. Point B is located over here in quadrant 4. Reflecting point B across the x-axis, it has to be 3 units on the other side of it. If point B is 3 units below the x-axis, then B prime is going to be 3 units above the x-axis. Reflecting point B across the x-axis, we can say the location of B prime is going to be 4, +3. Now pause the video and see if you can find the reflection of C and D across the x-axis. Reflecting point C across the x-axis, we can see that it's going to be 8 units below the x-axis. The location of C prime is going to be -7, -8. And reflecting point D across the x-axis, D prime is going to be located at 5, 0. Since point D is on the x-axis, if you flip it or reflect it across it, it's in the same location. Hopefully C and D both make sense to you. Pause the video and see if you can see a pattern between the original points and these reflections. If you notice that each of these y values just became the opposite, really good job. Since we reflected each of these across the x-axis, none of the x values actually changed. It was just the y values that became the opposite value. As a formula to follow, whenever you have a point x, y, and you reflect it across the x-axis, the new point is going to be x, -y, or x, the opposite of y. Reflecting across the x-axis, this is true 100% of the time. Now that we know how to reflect points across the x-axis, let's practice reflecting points across the y-axis. Using the same points, we're going to reflect these across the y-axis now. Let's start with point A, which is at -2, 7. Instead of our mirror being along the x-axis, our mirror is now along the y-axis. If point A is staring at this mirror, it is 2 units away. Its reflection across the y-axis must be 2 units on the other side. In this example, our reflection is going to be over here in quadrant 1. The coordinates of A prime are going to be +2, +7. What about point B? Well, point B is 4 units to the right of the y-axis, so its reflection must be 4 units to the left of the y-axis. Reflected across the y-axis, B prime is going to be located here in quadrant 3. Its ordered pair is going to be -4, -3. Now pause the video and see if you can find the reflections of C and D across the y-axis. Since point C was 7 units to the left of the y-axis, C prime is going to be 7 units to the right of the y-axis here in quadrant 1. And since point D is 5 units to the right of the y-axis, point D prime is going to be 5 units to the left of the y-axis. The ordered pair for point D prime is going to be -5, 0. Now pause the video again and see if you can see a relationship between the original points over here and the reflected points across the y-axis here. If you notice that their x values are opposites of each other, really good job. When reflecting things across the y-axis, their heights don't change or their y values don't change. It's important to know that when reflecting across the y-axis, only the x values are going to change. As a formula to follow, if you have any point x, y, and you reflect it across the y-axis, its new coordinates will just be the opposite of x, but have the same y. And that concludes this 2-part lesson on coordinate planes. It's my hope that you now have a much deeper understanding of the coordinate plane, how to plot points, and how to use them to solve different types of problems. Keep up the great work, and I'll see you in the next one.